Hello! In this video, we are going to derive the following identity. Tangent of x over 2 is equal to 1 minus cosine x over sine x, which is equal to sine x over 1 plus cosine of x. For all real numbers x, such that sine of x is non-zero. Now, it is in fact the case that for all real numbers x, such that sine of x is non-zero, each of these three expressions are defined. So we're going to show for all real numbers x such that sine of x is non-zero, each of these three guys are equal to each other. Now, let's keep in mind these three identities. These three identities hold for all real numbers, and we're going to use these three identities in this derivation. So let's start. Now, we're first going to show that these two expressions are equal to each other. Let me start out by writing the middle expression right here. Now, we're going to view cosine of x as cosine of 2 times x over 2. Similarly, we're going to view sine of x as sine of 2 times x over 2. And now we're going to apply these three identities. For our first identity, if we take alpha to be x over 2, well then we have that sine squared of x over 2 plus cosine squared of x over 2 is equal to 1. So we're going to replace 1 with sine squared of x over 2 plus cosine squared of x over 2. Now, let's apply this identity. If we take alpha to be x over 2, we have that cosine of 2 times x over 2 is equal to cosine squared of x over 2 minus sine squared of x over 2. So let's replace cosine of 2 times x over 2 with that. And finally, let's apply this identity. If we take alpha to be x over 2, well then we have that sine of 2 times x over 2 is equal to 2 times the sine of x over 2 times the cosine of x over 2. So we'll replace sine of 2 times x over 2 with that. And now, if we distribute the minus sign across this parentheses, we're going to get minus cosine squared and plus sine squared. And now we see that cosine squared minus cosine squared goes away, and we're left with sine squared plus sine squared. So that leaves us with 2 sine squared of x over 2 in the numerator. The 2's cancel out, and sine squared of x over 2 over sine of x over 2 leaves us with just sine of x over 2 in the numerator. But then we see we have sine of x over 2 over cosine of x over 2. Well, by definition, that's just tangent of x over 2. So, we have shown that this guy is equal to tangent of x over 2. Exactly what we wanted. So that shows that these two guys are equal to each other. Now we're going to show that these two guys are equal to each other. And I'll start by writing the middle expression right here. And to start out, I'm going to multiply both the numerator and denominator by 1 plus cosine x. Now, in the numerator, we're really doing something in the form of a minus b times a plus b. Well, if you recall, that leaves us with a squared minus b squared. So really we get 1 minus cosine squared of x. And in the denominator, we just have sine x times 1 plus cosine x. But then, by this identity, if we take alpha to be x, we have sine squared of x plus cosine squared of x equals 1. Well, then that implies 1 minus cosine squared of x is equal to sine squared x. We see that sine squared of x over sine x leaves us with just sine x in the numerator, and so we're left with sine x over 1 plus cosine x. And so we have shown that these two guys are equal. So all three are equal to each other. And so this completes the derivation. And so yeah, that's pretty much it for this video.